How am I going to be a YouTube celebrity if you guys don't like, comment, and subscribe? Everybody who needs the link in Discord didn't slam that bell, right, wherever it is down there. Or is it this side now? Whatever. Today we're going to keep looking at our little squares adventure when we last left off. Let's run this and see where we stopped. We were able to... yep, that's the right one. Move our square with WASD. And we were also able to use the arrow key. 6 likes in the first 30 seconds. I can feel like this is going to be a good one. You can move your square with the arrow keys and WASD. Can't move diagonally because that's unnaturally hard in Swing, remember. Probably going to be a bonus one day, so think about how you might do it. One of the things I might say is maybe a bug is that the circles draw on top of the square. Whenever the square overlaps one, the circles end up going on top of the square. We should probably have the player be the topmost object. So let's start out with a little softball. How do you do that? How do you make it so that the player is always drawn at the top? How do you make it so that the player gets drawn at the top of the scene every time? He's always the topmost thing to be drawn. Nothing can overlap the player and his beautiful hat. How do we do that? Where should we even search for that bug? You know, if we're looking at a bug like this with the drawing priority being an issue, where can we even look for it? So instead, rearrange the order of how things are drawn in paint components. So let's check it out. Here's our paint component. Pretty straightforward, right? We're drawing the player, then we're drawing the food. We need to draw the food and then the player. So we're just going to move the player down to there and then run it again. And there we go. Whee! Now he's on top of the circles. Alright. So obviously this looks a lot like the start of your next homework, right? Having to draw all of the different circles and things. And you can definitely copy a lot from this example into your homework. There's definitely a lot of room to take stuff. But I better not see your circles named food, or I'm going to take off for stupid variable names. Okay. So when we left off, we were trying to figure out how do we make it so that the player eats food when they collide with it. And we know we're going to have to put that in keep rest at some point because we have to put it after the movement occurs. So whenever the player moves, then we need to check if the player has collided with any of the food. And then if the player has collided with any of the food, then we're going to have to eat it. Okay, so how do you check if the player has collided with any of the 100 or whatever it is, 50 pieces of food in the scene? How do we see if the player has collided with any of the pieces of food in the scene? So similar to drawing and with everything else, when we have an array of items, we're going to have to loop through it, which seems like a lot, but it's not. So we're going through food.length here. Looping through that array. And then we're going to do something with it. So it'll be food of I dot something, we're not sure yet. This will happen after the player's key press is handled, so that it happens after the player moves. Now today, I want to introduce another little convenience feature, because I like to do at least one every day, right? So let's do another little convenience feature today. Some of you have already learned this from the tutors or whatnot, and it's called the fancy for loop, or at least that's what I call it, because it has no technical and universally agreed upon name. And it's a for loop just like the one that you see before you that loops through the whole array. It just has a fancier syntax, and it works on other kinds of lists besides arrays, which we haven't gone into yet, but you will at some point in this class too. So this for loop goes like this. So you specify the kind of object that your list is a list of. So in this case, our array is a list of food. You specify a name. I'm just going to call it F. And then the array that it's in, so the list that it's in here, and a colon between those things. And here's what it's going to do. So it's going to visit index 0 and it's going to set f, food f, to index 0. So it's kind of equivalent to doing this here. So food f equals food of I, right? And then the rest of the stuff follows. So basically these two statements here are equivalent. This is a fancier syntax. Now what don't you have access to here? What are you missing in the fancy for loop? There's something important that's missing from the fancy for loop. Not missing, like the syntax is right, everything's good there, but what piece of information do you lose by using this format over the more traditional for loop format with the I equals 0, I is less than food.length, I plus plus? What information have you lost by using the fancy for loop? What information have we lost? So what are the perks too? Well, it's shorter. Something to mention, although it doesn't really matter at this point to any of you. And I'm still looking for that answer, what did we lose? But some of the other benefits are that it's easier to understand. Someone said we lose the ability to iterate through only a portion of the array. That's right. But we've actually lost something even if we want to iterate through the entire array. We've lost a piece of info even if we want to iterate through the entire array. The other downside to the fancy for loop is that in most programming languages, Java included, it's slightly slower in terms of performance, but that's not really something you need to worry about. But some people, because they know that, just avoid it in all situations. But I would argue that you shouldn't do that because the fancy one is much easier to read in many different applications, and so I would encourage you to use the fancy loop in places where you feel like it improves readability. Don't worry about the performance of it too much. Until you're getting into millions of items, it's not a problem. So I haven't got an answer yet. I'll just give it away. You lost the index. You lost I. You lost the ability to access the index. So if you want to access the item at, let's say, I plus 1, which might be something that we want to do in loops, there's no food of I plus 1 here. Can't get that. So if you need the index, or you think you're going to need the index in the body of the loop, don't use the fancy syntax. Use the regular one. All right, so with syntax done for the day, let's look at how it is that we see if any of the food items are touching the player. And you might reuse a portion of this code, hint, hint, for the bonus on the current homework, because there is a bonus to make sure that none of the randomly generated circles on the screen like we have here touch. So they're all in different places. So these two circles, if this was the homework, shouldn't be touching. So none of the circles on the screen would be touching. These two shouldn't be touching. All right. So to see if a circle touches the player, we're going to check. I think I called him player, but again, one way I can check real quick if I forgot the name is to type this dot and then look and see if player is a valid field. The other way to see what the name of all the fields at the top are without scrolling to them is to use the outline view. So I can see that I have a player and a food. I can click on them in the outline to jump to them real quick. And then if I want to get back to mouse press, and click back down there real quick. I want to get back to key press, click back down there real quick. So a lot of people like to use the outline to navigate. All right. So if the player, I can use this, I can avoid it, whatever, it doesn't matter. Remember, it's inferred. If there's no other variable named player down here, it knows it's got to use the field, even if you omit the word this. Player is a rectangle, and rectangle has a method called, actually player is not a rectangle, player is a custom-made object. We want player's rectangle. How do we get player's rectangle? Actually, let me just do that as a question before we move on. How do I get the rectangle that underlies player, the base display, and the hat? I don't have anything for it here. So how do I get these two things? It's a trick question, by the way. How do I get those? How do I get that base display? Yeah, there's not a getter, so I can't yet. I can't get it. I'd have to add a getter in order to have access to the base display. But even if I could, right, if I wanted there to be access to both the base display and the hat, I would need two getters. That'd be kind of awkward, first of all. Second of all, if I want to check if player has collided with another object, that's logic that's based on the player. So that's really logic that I should be writing here inside the player. That's where I'm going to put it. I'm going to add it here. I'm going to call this method intersects. I'm naming it after the intersects method that exists in the rectangles. And before I fill in the arguments and everything, and the actual type, it's not going to be a void. Let me look at the intersects method that comes with rectangles and read the documentation here. So you have a few different variations. You've got one that takes a rectangle, one that takes 4 points, an x, a y, a width, and a height, so a rectangle but specified a different way, right? One that takes a line, so tests if a segment intersects the interior of this rectangle. A line is basically just 2 points though, right? And then another that takes 4 coordinates, which are the 2 points of the line. And then there's another that we're not going to look at. So there's basically 4 intersects methods that you have available to you. We're probably going to be looking for the one that takes a rectangle, right? But what's the problem with using the one that takes a rectangle for the task that we are up to? We're trying to figure out, I'll just comment everything out for a bit so that I can run it again. We're trying to figure out if the player has collided with any of these circles, right? And the player is a rectangle, but the circles, they're not. They're circles. So what's the problem with trying to use one of those 4 intersects methods that come with rectangle? Well, the problem is that we're trying to check for collision with circles. Circles are not rectangles, right? The food are ellipses, somebody said in the chat. So since we can't supply an ellipse as an argument, the best we could do is supply the square that surrounds the ellipse, which is something you did a couple homeworks ago. And then also on the exam, you have to generate the square that surrounds an ellipse, right? But the square that surrounds an ellipse is not the same thing as the ellipse, and that is not going to be as good of a collision, obviously. It's going to be, there's going to be parts of the ellipse that, or parts of the square that are outside the ellipse, and so that won't be a perfect collision. So what could we do to get perfect collision? What could we do instead? This isn't really as much a programming problem as it is a logic problem. What can we do instead of checking for intersection on the player object? I'll give you a minute to think about it. Instead of checking for intersection on the player object, what could we do instead? Knowing that we only have those 4 options, we can check for, well, 2 options really, but with different ways to specify it. We can check for rectangles or we can check for lines. And of course, we could also check for a single point. What can we do instead? Yeah, we can check for intersection on the food object instead, right? If we do it the other way around, if we check for intersection on the food, then we can supply the player's rectangles as arguments, because the player's rectangles are indeed rectangles. So that's fine. So alright, so I want to get the player's rectangles. How do I want to do that? Well, I said that getting 2 rectangles via 2 getters would be rather awkward, wouldn't it? So what could we do instead if we wanted to return both rectangles to you? So let's say I want to write a method, or more than one method that lets you get multiple rectangles. So it lets you get all of this player's rectangles. Ideally, again, you want it to be one method because you don't want to have to call multiple methods in order to get all the rectangles. That makes it difficult for anybody trying to use this later on, because if you don't remember that there's more than one, then of course you're not going to end up doing it, and then you'll have bugs. So unless you write it in the comment, and if you write it in the comment, there's no guarantee people will read it. There's no guarantee people will see it, because maybe they'll use a method that doesn't have that comment, and so forth. So you don't want to have to make people write multiple things in order to get your object started. That's a sin that Swing committed too, right, with all of this. You shouldn't have to do all of this in order to get the frame to appear. This is confusing, right? We don't like this. All this frame stuff. So what can we do to make it so that you can get all of the player's underlying shapes in a single method call? How can we get all the player's underlying shapes in a single method call? Yeah, we can return an array of rectangles. Haven't done a lot of array returning, have we? So, how do we return an array of these 2 items in one line? What's the syntax? This is a hard syntax. How do we return an array of 2 rectangles in one line? This is the tough one. I always forget the syntax too. I usually end up typoing it a couple times before I get to it. So you've got a little bit of a hint here on how to make a single one. How do we make an array of 2 rectangles containing these 2 guys up here and return that all in one line? I think everybody should be familiar with the multiple line version, right? So let's type that out as a reference while you're thinking about the one line one. That's the multi-line version, right? So there's a good recommendation in chat. Let's see, new rectangle 2D dot double base display hat. It's close. You're close. There's just a little, it's a little off on the syntax. There's a symbol you're missing. Anybody guess it? I know that this is a tough syntax, but you need to be more comfortable with it. Otherwise, you end up writing these really long statements. Yeah, we're missing the brackets somewhere. There we go. And that's it. That's it with our square brackets. So this is the same as that. Alright, so now we've returned an array of the 2 rectangles. Okay, so now we need to write a method for our food. Our intersects method will go on our food instead. So let's write that intersects method. It's going to be a Boolean. It'll return true or false. It'll be called intersects. And we're going to take a rectangle as an argument. Call it R. Okay, and it's going to be pretty simple. If the base display intersects the rectangle, then we'll return true. And if not, then we'll return false. Should we make a method here that takes an array of rectangles? We could. One thing we could do, let's document this first, returns true if the ellipse contains the rectangle, false otherwise. At least partially contains. That's what it means to intersect. Contains means that it fully contains it, and intersect just means that they're at least touching. So, something to think about already for your homework, right? How do you figure out if two ellipses are touching if you don't have intersects available? Because you can't use intersects, right? Because if they're both ellipses, I mean, you can do partial. If you get it somewhat working, if you use the rectangles, can you still get it somewhat working? Think about that. Do you need perfect ellipse intersection? Something to think about. I might be giving it away a little too much there, actually. So. All right, so we could make one that takes an array. So let's say we have one that takes an array of rectangles instead of just one. How should we write our version that takes an array of rectangles instead of just one? What should we change here? How should we write the one that contains the array of rectangles? We need to add a loop. But something that I saw a lot on the last homework was that you had a method to do something. I don't remember what it was. I think we were, I don't remember, calculating area, one of those things. And then you had another situation where you had to do the same thing, but you had to do it in a similar context. You just had a different argument. And people ended up rewriting it from scratch. So you had a method that does the same thing already, but you end up rewriting all the logic from scratch. That's not something that we want to do if we can avoid it. So we want to recycle as much as possible what we've got. And that means we want to recycle our intersects method, if it's possible. So how do we recycle this one that we already wrote up here? I mean, I can obviously just jam that same logic in there, right? And this works fine for the most part. I still need to make some improvements to the logic here, right? We need to return false at the end of the loop, and we need to not return false in here. Anybody understand why? Why do we need to get rid of that? Why do we need to get rid of this else return false here? Why do we need to get rid of that if we're going to do this for loop version? And remember the description, we're trying to return true if the ellipse contains any of those rectangles, false otherwise. So why do we need to remove the highlighted statement and put the return false at the end instead? Something of a programming reason, but again, it's mostly a logical problem, as a lot of the problems we will run into Swing are. So we're looping through the array of rectangles that we got. If the ellipse contains one of them, so if the intersect value is to true, then obviously we don't have to look at the rest of them. We can just return true because it's true if any one of them contain it. But if it doesn't, like the answer says in Discord, if, for example, it doesn't contain rects of 0, that doesn't mean that we can return false right there. We still have to check the rest of the rectangles only when you've checked all of the rectangles, and none of them have returned true. Then you know that this ellipse doesn't contain any of those rectangles, and you can return false. So you don't want to return until you've checked all the rectangles, as in when the loop is finished. So this is a common logical play that you'll see. So keep it in mind. The logical structure of loop through all of a list of items. If one of them meets the criteria, return true. And then at the end, if none of them meet the criteria, return false. We'll see this break down a lot. All right, so this is fine, right? Fine as is. But what we should do, really, is reuse the intersects method that we already wrote. That way, if we ever make changes to this logic, I don't think that we will, but if we ever did, then we would only have to update it in one place. So how do I change this line here to utilize the existing intersects method that we already wrote? It's actually a pretty simple change, and a demonstration of how object-oriented syntax can get very confusing indeed. How do we make sure that it uses this intersects method instead? So if I was to hover over this, it would give me that documentation, rather than what it's doing now, which is using the intersects method that it gets from base display the ellipse. How do I change that statement? I'll post the statement so you can edit it without retyping it. And if I change that statement to utilize this intersects method instead. I might have given you a little hint there. Subtle hint. No, right now it's using the intersects method that it gets from base display, which is an ellipse. So it's using the ellipses intersects method. I want to use this one down here that I wrote. So I want the version that loops through the array of rectangles to use the function that I wrote for a single rectangle repeatedly, which is better because then if I end up changing the logic for this, if I down the road decide that I want to change the way an individual rectangle is handled, then I only have to change it in one place. Whereas let's say, I don't know, I wanted to do something different here. Who knows what crazy things I wanted to do. Maybe I want to do something like that, right? If I ended up wanting to do something like that, I would have to change it in all the different places where it appears. I don't know, whatever I want to do, whatever kind of logic I want to add. Doesn't matter, but I have to change it in all the places. Maybe I just want to print something. Maybe I just want to do something as simple as, grabbed an intersection, right? So if I wanted to add that print statement, and I wanted it to work for the array version, well, now I'd also have to paste it up there because it doesn't use this method yet. But if it used this method for every individual square, then I wouldn't have to make any changes. Change the name of the method to what? What do I change this line to? Or should I change the name of this method? It's fine, again, to have two methods with the same name as long as they have different arguments. And the fancy word that is used to describe this phenomenon, the having the same method name but with different arguments, is function or method polymorphism. So if you hear that fancy and very stupid sounding word, this is your first example of it. The fact that one method name can serve multiple purposes. So at override now. Now what at override does, we'll see a bit later. So nothing what we do in the midterm here will use at override. At override's only used for these functions that are generated for us automatically after we import the mouse and the keyboard listeners and stuff. And I should point out that if you get rid of them, let's see what happens when you get rid of them. Nothing. It still works. So we'll learn about those later, but not that important. And what you're really looking for override is these little arrows over there. The other situation where we did an override was when we did two string methods earlier. And again, we saw that little arrow pop up on the side that indicated we had done it successfully. So how do I change this line to use the intersects method that I already wrote for food rather than the one that comes from ellipse? How do I use the intersects method that I just wrote here instead of the one that comes from ellipse? This might be an argument for not naming all of your methods the same thing. I bet it would be easier if I called it something else. I'm sure you would be able to figure it out, right? If it was called something else, then how would you do it? Someone did propose to change the name, so... And now you can see, by the way, that it's not using it. I've changed it to something else, and there's no error here, which makes it obvious that you're using a different intersects method. But of course, the easiest way to see which one you're using is to hover over it and see what the documentation says. This one comes from java.odd.geom.rectangle.intersects, not from food. Base display dot something else? Well, base display is an ellipse. So base display doesn't have a something else function. Food does, but base display doesn't have an intersects function. So it wouldn't be base display dot something else because base display, the ellipse, doesn't have a something else method. Food has a something else method. So how do we call foods? This piece of foods, something else method. There we go. This dot something else. That's correct. Of course, you could omit the this too, because it's inferred. And now, naming it intersects again, for the easy answer, what would I do in this situation then? What's the final answer? How do I phrase that line? Yep, just this dot intersects. Okay, so how does it figure out which intersects method to use? We call this a polymorphic method invocation, because you're invoking a method that has multiple variants of it. Remember, intersects is polymorphic. That means there are multiple methods named intersects, and they take different arguments, but they have the same name. All right, so how does it know which one to use? Well, it just looks at the arguments. And that's a polymorphic method invocation. Since it's getting a single rectangle as an argument, it knows to use the single version. Returns true if ellipse at least partially contains the rectangle. That's this comment that I wrote here, right? So it's using this one because that's the one that matches the arguments that it gets. And as always, we could omit this keyword, and it would still work because it's still not ambiguous. There's still only one intersects method that takes a rectangle as an argument. I'll keep it because we had base display dot intersects before, right? And so if we're just substituting base display for this, it makes sense to me to keep it there. It makes it clearer that we're not using base displays intersects method. You can see just by looking at it, we're not using that, we're using foods, this object's intersects method. Alright, so that was pretty complicated, right? But keep that in mind, that sometimes we're going to write methods that have the same name as the ones that come from ellipse and color and whatnot. And then we're going to want to use hours. And the best way to tell which variant you're using is always going to be to hover over it and see where it comes from and what the comment says. This one comes from squareadventure.food, obviously. That's the one I'm looking for. Alright, bringing this all together, going back to display, I was looping through the food items. So if the piece of food at F intersects, and then we want players rectangles. I'm going to use the array version, and I want to supply the player's rectangles as an argument. What's the syntax for this line then? How do I get the player's rectangles again? It can be player something. Is it just player? No? What does Eclipse recommend? It's not smart enough to figure this one out. Yeah, I have to use that getter that I made. What did I call it? Well, I probably called it something with get. That's the advantage to naming all your getters get something. So if F intersects player.get rectangles, what did I actually want to do? I wanted the food to get eaten, and I wanted the player to get bigger. So we want the food to be eaten, right, and then player gets larger. Okay, so food gets eaten, player gets larger. Let's handle the first one first. How does food get eaten? Food has a variable called as eaten already, and food has a draw method, and if it's not eaten, it gets drawn. If it is eaten, it does not. So how do I set the food to be eaten? It's pretty simple. F equals eaten. F.eaten. What's the problem here? Oh, I called it is eaten. Duh. Alright, is eaten. That's true. Alright. Next problem, player gets larger. Okay, how do I make the player get bigger? Let's go back to my player and see. So I have these two rectangles that player is based on. And I don't have any kind of size variable anywhere. When you make the player, at first, you get a width and a height. And then you don't get them again. And there's nothing done with them. And remember I said that you don't need to make a variable for the width and the height, because you can just access it from base display. The player's width and the player's height are always equal to the base display's width and height. That's just how we designated it. That's how we've decided to specify it. So how can I make the player get larger? I don't have anything here to do it. Let's write a method that does it. We'll call it enlarge. Or we could even call it what it really is, because we've done this before, scale, right? So yeah, let's call it scale. Let's take it as doubles, because our width and height are doubles. Multiplies the player's size. Well, let's say the player's width by x and height by y. Alright. How do we do that? Well, remember we don't have a width and a height to consider, but we do have the width and the height that's attached to base display.width. There's also a getter for it, base display.getWidth. How do I set the width of the base display to the width of the base display times x? So let me say base display's width is the width times x. Yeah, pretty simple. Because it doesn't require a getter or a setter, it's just a public field. We can modify it really simply with a statement like that. I guess another little syntax trick for the day. You've probably used plus equals before, but did you know that you can do it with every other math operation too? You can also times equals things, divide equals things, and minus equals things. I find the syntax kind of but totally up to you. You definitely see it out there every once in a while, so you should at least be familiar with it, even if you don't like to use it yourself. So same thing for the height. We're going to times equal by y. Same thing as plus equals, right? This is shorthand for base display.width equals base display.width times x. So you get to skip saying base display that second time. What else am I forgetting here? What else am I forgetting? There's something else that needs to be placed properly. In the meantime, let's run this, and then maybe you'll see what I'm forgetting. So player.scale, and we'll just say 1.1 for now. Maybe we'll change it to some proportion of the food size later, but for now we'll just say 1.1. Yes, I'm forgetting the hat, right? Let's see. Oh my, you get quite large, don't you? Very fast, but your hat does not. Should your hat grow? Up to you. There's one more bug at play here, though. Watch. I'm going to hit the circle, and I got bigger. And then I'm going to hit the A key again, and I keep getting bigger. And it also prints found an intersection very, very many times. So what's up with that? Well, since we lost our train of thought, we need to leave ourselves a to-do while we go and fix the other bug. What's up with that? Why does it keep getting bigger and bigger? Let me show you the bug again. So as you run into, let's say I'm going to run into this big green circle over here, I get bigger once, and then as I keep hitting the arrow keys, I keep getting larger. What could it be? Where should we look? A little hint is the fact that we're seeing this found an intersection statement happen so many times. You see it once when I first make the collision, and then it continues to print. That statement, as we know, comes from here. So it can only happen if an intersection was detected. Someone said the ellipse is still there. That's right, even though we're not drawing it anymore. So when is-eaten is set to false, we're not drawing the ellipse anymore, but it's still there. Just because you don't draw it to the screen doesn't mean it isn't still there. An invisible ellipse can still intersect with a rectangle. Okay, so even though the ellipse is invisible, it's still able to intersect with the rectangle. This can be useful at times. You can set up events to happen when you get to a certain part of the screen without actually having a UI element there. So for example, if you wanted to do something when the player entered a particular part of the screen, but you wanted to keep that part of the screen hidden, like let's say it's the end of a maze, you can put an invisible box there and check if they've intersected that invisible box. But in this case, it's really a problem for us. So how do I fix it? How do I fix it? How do I make it so that eaten food does not intersect anymore? How do I make it so that eaten food does not trigger an intersection anymore? It would return false, I would say. We need more people answering these questions. We don't have nearly enough dumb answers. But really, it's a very low stakes environment. You can answer however you want, and it'll still be valuable, even if you just meme it. Don't be afraid to give me an answer, because even a dumb answer is better than silence. And dumb answers are how you learn. No judgment. Practically anonymous on Discord anyway. It's absolutely zero stakes for you to try to answer a question. The more you answer, the more you'll know. Alright, so ignore some value? No, we could. Okay. There could be a better solution. We could move the ellipse or shrink it. We can move it off the screen. We could do that. So right now, the way you set something to isEaten is just to set the field. If we wanted to do more, if we wanted to move it off the screen and stuff, then we would probably have to change it to private and add some sort of getter and setter functionality. So let's do, we would have to do like a get isEaten that just returns it, and then a setter that, in addition to setting it to true, also moves the ellipse down the screen. So that's a lot of extra work. I like the most recent answer the best. Just add an if statement to check if it's eaten, in addition to everything else in the intersection. So we've got our current thing that checks if the base display intersects. We should just add a check to see whether or not it's been eaten to that first. So the syntax that was offered there in Discord works, but it's a long one. When we have special cases like this, sometimes what we do is a syntax like this. We have if is eaten, return false. I like to call this like the quick escape syntax or the edge case syntax. You'll see when you have a method that has a lot of edge cases or extra circumstances behind it, you'll see this kind of logic. I like it because as long as the spacing in this kind of syntax is accurate, you can tell that all of the stuff at the top are just the edge cases. So if it's eaten, then don't bother checking the logic. Return false immediately. Eaten shapes basically have no intersects method. So I do like this syntax too. Other people prefer to jam all the different conditions that are satisfied into the if statements. This can be more difficult to do because sometimes they aren't as related as you might think. So for this one, it's pretty straightforward. If it's not eaten, then we can proceed to check the intersection. This actually has the same effect as the previous syntax because Java is smart enough to know that if an if statement failed, and then there's an and, it doesn't need to continue. So we will only check this, and if it's already been eaten, it will go straight to return false and not evaluate the rest of it, which saves you from having to perform this intersects call. Not that it's particularly computationally expensive, but it's not free, and so that's an optimization that leads to a lot of time savings. So either of these syntaxes are good, and then the one provided in chat is fine too, although probably my least favorite, putting them around like that. So if not is eaten, then we're going to do everything inside, and then we need an extra return false at the end. So this one's only not my preference because if you end up having more edge cases, like let's say there's something like if not, I don't know, if it's delicious or something, and then you end up having an edge case for that, and then, alright, let's say you had another edge case down the road. If widget is less than 3, you know, you're going to end up with a very nice nest of statements very quickly. That's no fun for anyone, so I prefer one of those other two syntaxes. I'll bring it back to, let's say this one, which is probably my preference. And do we have to make any changes up here? Do we have to make any changes up there? Yes, no. Usually I post that in general, but you didn't have to delete your no. You don't have to bias people. You can bias people. Do we have to make any changes to this one up there? I put the poll in the in-class chat today. So no, we don't, because we already used this intersects method in that one. And that's what I'm talking about when I say that you don't have to double up any of the logic here. You now can rely on just having to make changes in this method, and they will apply to the array version as well. Alright, so if it's eaten, we're going to return false. Those shapes can't intersect at all. Alright, so try again. Now we get the square eats all the different foods only once. Yum, 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 yum. Impressive. Okay, so hats don't grow when you grow, obviously. I mean, we know that. That's just math. Hats don't grow when you grow. But hats should move. So how do we make sure that anytime the player grows, the hat remains centered? Anytime the player grows, the hat remains centered. We centered the hat earlier. We had its x and y location placed at width over 3 and height over 3, right? But now it's a little bit more complicated. What do you do when it's a big rectangle, little hat, and unlike in the original, the hat's proportions are no longer based on the rectangle's proportions at all. So we want to get this distance, the distance between that top left corner and the hat's top left corner, not to be mistaken with this distance, which is the distance to the true center of this shape. Okay, so we have this slightly shorter distance that brings us to that top left corner, which is, of course, what we're specifying when we specify rectangle placements, not to be confused with this distance there. Luckily, we can keep the hat's y value the same, because as squares grow, as rectangles grow, they grow the same way our squares did when we scaled them. The top left corner remains the same, and they just grow outwards in that direction. So the y-coordinate of the square doesn't change as it grows out. It scales outwards towards the bottom right. So luckily, we don't have to change the y-coordinate at all. We only have to change the x-coordinate. So what is this distance here that we're trying to figure out? This distance there. Well, this distance is pretty obvious, right? The distance to the middle, that's going to be width over 2 of the big guy, right? What about this teeny-weeny little difference there that brings us up to it? It's this teeny weeny, you can probably barely see it distance, halfway to the hat. Well, that's obviously the hat's width. Hat's width over 2. So put it all together. We want the hat to be width over 2 and hat's width over 2. Something to do with those 2 items. Put it all together. Hat.x equals. Now it's always x plus because we're always anchoring it to that base displays x. Base displays x plus what? Or minus what? Or times what? Not giving it away. Yep, so we're adding the base displays width over 2. That's this first red line here, and that brings us to the center. And then we're going to subtract half of the hat's width in order to center it around that point. So we've done this a few times here, but just to reinforce it again, that subtracting of half of the object's width in order to center it is a very common thing we have to do in Swing because of that top left corner placement for everything. Alright, looking good, but I actually don't like the way that this functionality works. I don't want to scale it, I don't want to multiply it, I want to just add to the size. So let's add to the player's width by x and height by y. I'll call this method enlarge instead, and the only difference is going to be that it'll be a plus equals instead of a times equals. So I'm going to add to the player's x and y instead. Because with the version that I had, as you could see, the square multiplying by 10% gets you really, really big very, very quickly. Alright, so I'm going to go back to my display and change it to use enlarge instead of scale. And I'm going to add a test value for now. Let's just say 10. Okay. Whee! And the hat remains centered. Very cool. And of course you can't get massive now. You get pretty big, but you don't get absolutely massive right away. It's a very fun game. Alright, so how about instead of adding just 10, I want you to be enlarged by the size of the food. So the square should gain some proportion of the food's width every time it eats a piece of food. So how do I change it? Change it so the square gets the food's, let's say 1/2 of the food's width instead. Or not with the 1/2, it doesn't matter. How do I change it to be proportional to the food's width instead? Too. Finish that to do. So I want to get the foods width. That comes from the base display, so good catch there that we're not going to be doing food.width because food doesn't have a width. It's the food's underlying display that has the width. Now, unfortunately, I went and made that private or protected or something. Oh, actually, no, I just said food instead of F. So no, you could just get the base display like this and get the width, because I did leave it as default, which is public for our purposes. So we could do that. That would work. This is a little bit wordy, right? A little bit wordy. So my preference in this case would be to add getters for the kinds of things that we want to see here. I like to put all of my getters at the bottom. So in this case, I would probably like to add a getter for the width so that you don't have to call on the base display. So I would do something like return base display dot width here. But then you don't have to call on the base display, which is kind of an awkward thing to have to do. You can just call the get width instead. So one line rather than two. The more series of dots you have like this, the more complicated it is. Obviously, you don't want to go very deep into different objects fields. So I consider that to be a little superior there. But all right, let's see how this works. So the bigger the food, the bigger you get. So the big ones give you a lot of size. The little ones give you hardly anything at all. That one gave me hardly anything. This one's going to make me giant. Woo! Look at that. Okay. Next order of business is to add some of that competitive edge to this game. If you try to eat a piece of food that's bigger than you, you die and the game ends. Okay, so if you try to eat a piece of food that's bigger than you, you die and the game ends. Where do I need to make that change? I completed this. Where should I check for the size of the food and make sure that it's appropriate? You've heard that game concept before? Impossible. I just came up with this. It's brand new. Nobody has ever made a game like this before. Note that we still want to do this when there's an intersection, right? Look, it's not plagiarism because mine has rectangles. Find me a game like this that uses a rectangle. You can't, okay? So mine is brand new. I'm not copying anybody. We still want to perform this check for the food size after we've verified that they touch. So it has to happen after the intersection. But where? Where should we perform this check? These are the kinds of questions that you're going to run into a lot, right? And this is how I want you to get into the habit of building your features one at a time. Pick the one you think you can implement and implement it, but plan ahead. So what do I mean by planning ahead? Things like making sure that we reused the food intersects method in the array version so that we didn't have to apply all these changes. That was thinking ahead. Making sure that we have a simple quick return on the intersects method here instead of like a deep if statement that's hard to read. That's thinking ahead to an extent. Nothing here is tied together in such a way that the question that I'm asking you is difficult to solve. The whole not allowing the square to eat bigger food is still pretty doable within the framework we've already built. But if I asked you to build this completely from scratch, if I said build agar.io rectangle addition from scratch, maybe this isn't the approach that you'd come up with. But I want you to still get in the habit of building things piece by piece. But back to the original question. So we want to check if the player is bigger than the piece of food. If they're not, then they die. So when you hit a piece of food, if you're not bigger than it, then you die. We want to add an if statement, but where? Here? There? Maybe here? Where do we add the if statement? Now luckily we're only dealing with rectangles and circles, so we don't have to worry about width and height. We're only dealing with squares and circles. We don't have to worry about width and height right now. What do I mean by bigger anyway? Right? Do I mean area? Comments in chat said width. I guess width is fine. Alright, so we're thinking 83. The problem with doing it on 83 is that we haven't detected an intersection yet. So up here, there's no intersection, and we only want you to die if you hit a piece of bigger food. That means that you have intersected it. So we still want it to be something that happens after an intersection. So we still want to loop through all the food in the scene. And then after there's an intersection, then we want to check. So it used to be 88. I just moved some stuff. But yeah, we were talking about right here, basically, is where we want to put it. So we're going to check if... I keep moving it on you. Check if the rectangle's width. What's that? So something here that represents the player width, how do we get it? Is less than f.getWidth, so that one's pretty straightforward. Then die. And then otherwise, you get to eat them. I'll leave myself a to-do. How do I get the player's width? How do I get the player's width? I could get the player's width by player.baseDisplay.width, except I actually did make baseDisplay private because I didn't want you to be able to change it without changing the hat's position. So I'm probably going to need a getter for this. That's probably the easiest way. So I'll do public double get width here as well, and I'll return the baseDisplay's width. And this is not just a simple getter because there are multiple shapes here, so it's a little bit more complicated. So this is an example of one of those getters that probably does need at least a brief comment. This returns the width of the base display, which is the main shape. Okay, it doesn't return the width of the hat, it returns the width of the base display. So now that I have that in place, how do we kill ya? How do we add the functionality to die? Do we need some new fields or something? What can we do to die? Got our base color and our hat color, and got scale and large. Get rectangles, draw, handle, key press. Same thing I did for the food, so I can add an isDead variable here. I could do that. I could have public boolean is dead. That's going to be false. And then we're going to draw you differently if you're dead. So let's do that. This is something you did for the previous homework with the flipping of the cards and the colors probably. You had some sort of variable that tracks whether the card is flipped or not, and you drew it differently depending on whether it was. So if you're dead, what do we want to do for you? Something. And if you're not, then something else. Draw your hat and everything. Alright, so how do we draw the dead variant? Let's just say that you end up setting your color to red, and you lose your hat completely. No more hat. Your hat falls off when you die. And what else? What else to designate that you're dead? Besides the change in visuals, what else should be affected by it's dead? What should you not be able to do if the game is over and you've lost? Yeah, you shouldn't be able to move, which means that I should probably get one of these methods, the handle key press or the other handle key press, not to work. Maybe both of them not to work when you're dead. So again, the simplest way to do it, add one of those special cases to the top. If is dead, then we're just going to return without handling the press. This is a void, so it doesn't return anything, but this allows us to terminate the method early if a special condition is met. You could do the same thing here as well. So if is dead, we just return immediately. All right, let's try this out. One last thing, of course, is actually killing the player. So player dot is dead equals true. And it's probably better to make that private and write a setter for it, something like player dot die. Okay, so try to eat that guy. Nice, I was big enough. But this guy right here, this is iffy, but I'm going to risk it. Oh, I died. And now I can't move. It still prints found an intersection, and actually just kills me repeatedly because I'm stuck up against that thing. But now I can't do anything anymore. So our last order of business is to reset the game, because I want you to be able to restart it without, having to completely restart the application every time. So how do we reset the game? I'm going to detect if k.get key code is equal to, let's call it z. I'm going to look for the z key. Z is going to be my reset key. Alright. So what do I do to reset the game? How do I restart the game with you not being dead and everything? You not being dead, 50 pieces of food back on the screen. What's a simple way to restart all that? Well, why don't I just do exactly what I did to initialize it in the constructor? I might get rid of the challenge, because it's not a challenge this week. I don't think anyone solved it anyway. Why don't I just do everything I did in the constructor? So I'm going to remake all the food. Okay, I also have to remake the player, which I actually didn't do in the constructor at all. I did that up here. Okay, so I'm going to have to remake the player. So I create a whole new object for the player, and I create a whole new object for all the pieces of food. I can't use width and height down here because those were local variables in this constructor, but I can use panels width and height, which you can get with get width and get height instead. Okay, so anytime you lose, you can reset the game by pressing the Z key. So if I go around here and die, and I press the Z key, it starts me over. And then, of course, I die immediately, because that was an unlucky spawn there. And back we are. That's a risky move. Nothing can stop me now, right? Okay. That's it for today. Thanks for tuning in. See you guys next time. Don't forget about the homework. We're gonna review the last homework probably next time, unless no one's really interested, and then we will review the upcoming one, maybe on Thursday. Okay, see you later.